Today, we will be focusing on the Stage 3 syllabus that explains how energy is transformed from one to another. In the Explore phase, students worked through various stations, which included identifying different energy transformations, worked on interactive computer games to understand various energy transformations, and drew pictures to illustrate their understanding. In the Explain phase, any misconceptions were able to be clarified, and the students engaged in an interactive presentation which involved categorising types of energy into kinetic or potential. Here is an example of an interactive game students would have completed in the Explore phase.
As energy flow, put the pictures in order to show the correct flow of energy. When you think you have the energy flowing properly, hit the check mark to see if you're right. Sun, banana, Renee. Yes! The solar energy from the sun is used by the banana to grow. A hungry Renee eats the delicious banana to supply her body with energy. Now try putting these energy sources and users in order. Power lines. Television. TV show. Television. TV show. Good! The electrical energy carried by the power lines is transported to the house and used to power the television. The television converts electricity into light and sound energy, so we can watch our favorite TV shows. Put the picture.
Here is an example of an interactive presentation the students would have completed in the Explain phase. Today, in the Elaborate phase, students will be expanding their understanding of the transformation from light to heat energy. Prior to today's experiment, the students would have worked with partners or small groups to create their solar ovens. Today, for the Elaborate phase, students will be experimenting with their solar ovens to identify the energy transformations that occur. Students will be provided with eggs and tomatoes to cook in their own ovens and will be asked to take photos of each step of the process with their iPads, as well as record the temperature in the oven every 20 minutes. Once students have established if they are able to cook the food in their solar oven and are able to identify the energy transformations that occurred, the students can scan the QR code that would be displayed on the smartboard and individually fill out the survey. The survey will consist of questions such as what energies were used, was the oven better in the sun or shade, and why. The survey will assist in determining which students are working below, at, and above average. The next step in this phase is for students to create a PowerPoint presentation that includes their time-lapse photos from the experiment and label the energy transformations that are occurring. The presentation should also include a column graph with the oven temperature and time in the 20-minute intervals. This can be done through Google Presentations and Sheets. Finally, in the presentation, we asked students to first explore the energy transformation simulator and then create and screenshot the circuit that best represents the transformation process that occurred with their solar oven. We asked that students incorporate this screenshot into their presentation. Students will create their own QR code and link their presentations, which other students can scan, allowing every student to have a copy of others' results. Now let's look at what we found. Over the process of an hour and a half, the solar oven rose by 35.1 degrees. The egg only partially cooked, with the egg whites slightly turning opaque. We used both the tomatoes and egg to compare them over the process. The egg showed the most change, while the tomatoes were just warm to touch. Let's look at our variables for the experiment. Our independent variable was the time. Our dependent variable was the temperature, and our controlled variable was the food and the oven position. What would we do differently if we were to conduct this experiment in the classroom? While we could not control it this time, we would aim to do it in summer for the students to see a more drastic change. The only thermometers we were able to purchase was an outdoor one and a meat one. Next time we would ensure we had a more accurate digital thermometer that could reach a higher temperature. Okay, so now we're going to pull out the food that's been sitting in the sun for about an hour and a half and have a look at what it looks like and feels like. So our egg, I'll do first. As you can see, the egg, it's going to be hard, but it's quite opaque. And if you touch the yolk's gone all like hard from the sun. But it's not an edible cooked egg, but it's pretty well cooked.
And then with the tomatoes, they look the same as when we put them in. They're a little bit warm. They've got a little bit mushy, I'd say.
Yeah. And the edges, if you can see around the tomato, have kind of gone a bit. They've crippled in a bit, so they've like begun to cook. But
if we kept them out longer, maybe they would have cooked more, but we just didn't have enough time.
Yeah, or if it would have been a hotter day.
Yeah.
Science is a part of our everyday